This episode is about learning. Well, I try to keep it about learning, but a bunch of tangents do inevitably show up. But it's mostly about learning and how it happens in the brain. And I'm joined by Dr. Marijn van... I can never say his last name, so it's just Dr. Marijn. We talk about the brain, how the brain learns, what it's doing when it's learning, etc. Some neurobiology. And I think you'll really enjoy it. I do relate some fairly personal stories. It's just for context, and honestly, I don't have a problem sharing these things with people, so take it with a grain of salt. And none of it is advice that I'm trying to tell you. It's just me relating my own experience. Also, I mentioned a quote somewhere in there that says it's something along the lines of, what you do when you don't have to determines what you do when you don't have a choice. It's actually a quote from, I think, Oscar Wilde, who said, it's what you read when you don't have to that determines what you will be when you can't help it. I think it applies in either case, and that's something to think about. All right, that's it. Enjoy this episode. Catch you on the next one. Marijn.
Udesh.
Back again.
Here
Nice.
we are.
Yeah, this is cool. This is my second recording in person, but I'm glad we could do this live instead of doing it online. Now I can see your face.
Yes.
As I ask you all my pointless questions. But okay. So I already told you what I want to talk about today.
Learning, right?
Yes. All right. How do you want to? We can take this anywhere you want, because this is sort of like up to you. But how I got in, why I wanted to do this particularly was, I was reading about reinforcement learning in computers and machines.
Yes.
And I have my journal club, which last time we spoke about, we discussed the reinforcement learning paper that introduced deep reinforcement learning.
Okay.
So which got me like, okay, I need to figure out how this is happening in the brain, right? And last time we talked about dopamine. I feel like it's going to come back with a force in this topic, but
Definitely. Yeah.
all right, up to you. How do you want to do this?
Well, maybe we should start with a question. What is learning for?
That's a good question. Well, okay, I have the first thing that came to mind was how not to fall into pits that you've already fallen into. It's like,
It's a good one.
right? It's like why should we learn,
Yes.
right? Well, I don't know. Why should we learn? You tell me.
Well, if we go all the way back to like cellular organisms living in primordial soup, they're navigating in 3D space basically, and they have to figure out where should I go to get nutrients. And those are usually detectable by following some sort of gradient, chemical gradient in the water, for example. So basically, any organism that develops a way to sense such a gradient is going to optimize their future stream of income.
Sorry to interrupt, but one interesting, I was curious about when did evolution figure out to store energy when it found it, right? So like how long ago was it that a mechanism for storing energy in terms of fat or some other substrate evolved? And it's like hundreds of millions of years ago. Like,
yeah,
it's like almost as soon as life emerged, it was like, holy shit, we cannot reliably predict where we're going to find the things we're going to find. So we're like, when you find it, we're going to store it somehow.
You need some storage.
Yeah. But that's a cool thing. Anyway, sorry.
Well, energy is bound up in atomic connections even, right? So basically making two atoms stick together, that is a store of energy which can be released. And so if you go to biology, the main store of energy in this current cells basically is ATP, adenosine triphosphate, and it gets converted to ADP, diphosphate, and a loose phosphate, and releases energy.
It's called the Krebs cycle?
So in the Krebs cycle, you can make ATP basically. So with biology, most of the processes are somehow reversible, right? So there's basically a balance between ADP and ATP, and making the process go from ADP to ATP requires energy. So therefore, it's less likely to happen under thermodynamical rules, basically. So we have to put some energy in there, and that's usually done by burning any kind of sugar or carbohydrate. But if you go even further back to plant-based energy storage, we have to talk about chlorophyll, the green pigment that is capturing sunlight, basically.
As energy storage?
Well, I mean, that's where it starts. So the energy comes from the sun, right, in photons with energy, and that energy of the photons excites certain pigments in plants, and that energy is then directly sort of transferred. And I don't exactly know how that works, but it is used immediately, right? So that energy cannot be retained. If there is no chlorophyll around, you cannot hold on to the photons until some later time.
Isn't that crazy?
Right? Yeah.
Like that's nuts, right? It's like the fact that evolution figured out a way to use this giant thermonuclear reactor
Yes.
that is hundreds of thousands of miles away.
Yeah.
And he was like, I mean, it didn't go, but like, but he was like, over millions and billions of years of just like trial and error.
Yeah.
It was like,
this is a good way to do it.
yeah, it's crazy, right?
Or at least
nuts.
it's better than all the alternatives that we have tried.
Yeah.
So imagine what would have happened if our planet didn't have axial rotation, but would be facing the sun always from the same side.
Huh. Well,
then there's continuous input of photons.
Yeah.
And basically you could compare it to building an electric vehicle that is directly powered by solar panels rather than a battery inside.
Right.
So as long as the sun is still there, you're good to drive.
Right.
If there's a little cloud,
I see, yeah.
You're stuck.
Yeah.
And don't try to go under a bridge.
Yeah. It's game over for you.
So any system that builds in some temporal borrowing machinery from itself, basically, is just vastly more adaptive. If you think about maths or gradient descent, basically, it's a way of getting over a local minimum, basically. And so you want to have some momentum that allows you to carry you to to the next possibly better point. If you run out of energy before you get up the hill, you're going to fall back basically to this position. Now so let me digress a little bit.
No, please go ahead.
There's an amazing species. I think it's called like it's some species of vampiric bat basically, and they are living really at the edge of what is possible for a being, because they've optimized their body weight and their capacity to store blood to such a level that basically if they go without taking food 1 or 2 days, something like that, they die.
So they have no mechanism for retaining the energy that they found.
They use a lot of energy, and basically, so they're continuously on this hunting cycle it's like subsistence farming, basically. So there's absolutely no reserve, and if you fail a crop 1 year, you're done for, right? Yeah. That's what we used to be like.
Yeah.
As well. Now, what have they done? Similar to humans agglomerating in a way, these vampiric bats, they actually share blood. So if one person of the group or one individual is running a little low, they might go to their friend who has maybe had a successful run and take some of their blood, basically.
Like regurgitate the blood? Or like
I don't know exactly how it works.
Like he's like suck the other dude's blood out.
I think they will just,
It's like a chain of vampires.
Yeah.
Oh, man. All right.
So what do you need to do that? Well, you need some measure of reciprocity, right? So either it is like a polyamorous free-for-all between all the bats and everybody just takes whatever they want all the time, or you want to have a sort of a system for keeping a reputation. So who has given me some blood in the past and who do I owe some blood to in the future? And we talked about this in the decision-making part of the course. That requires then a whole social brain to develop and to keep track of these reputations and to detect who is a trustworthy partner, basically. Okay. Well, if you're just working with energy inside your own body, you don't need to keep track of who is a trustworthy liver or anything. You just have one, and that's the one that you get. Building up a store of energy basically allows you to take bets on the future. And you can exploit a bit more, explore a bit more rather than just exploit. And this relates to, for example, optimal foraging theory, which tells, assume that you're a bear, and you're fishing salmon from a river, and you figure out that after a while they're running out, basically. So you're still investing the same amount of energy, but the return is diminishing. So at some point, there's probably an optimal point for you to stop fishing this particular river and maybe go somewhere else and try your luck there. But that is a risky choice, and you're basically changing between exploiting your current situation to exploring the space of opportunities.
Right. Okay. Yeah, this is a thing I could talk to you about for a while. Exploration versus exploitation. But yeah, go on.
Well, so and it basically the level of storage that you can muster necessarily dictates how much exploration you can do. Right? How quickly do you need to get back to your home base before you run out or die, obviously.
That's cool. But also, I guess, is it also depending on the environment? So if you're like an elephant, right? And you can eat pretty much anything around you. I don't know if they can eat more. Herbivores can eat pretty much any plant, right?
Right.
I'm sure there are some plants that are they have chemical irritants to keep them from eating whatever.
Sure.
But if you sort of have learned that your environment is basically completely abundant, then you can go by without having much of a storage thing and just learn how to wander around. And I'm saying it'll increase your range of how far you can go around looking for things.
Yeah. Well, if we take a look at human cultural evolution, I think that once you have food stability in place, it allows you to specialize, because not every member of the tribe needs to be concerned with food gathering. And basically you have a surplus as a collective. And the people who are not specializing in hunting or gathering, they trust their tribe to provide for them because they're specializing in something else.
Interesting.
Yeah.
It's what animal? So the learning. Okay, I think so. Should there be a distinction made between the kind of learning that humans do and the kind of learning that other animals do?
Well, this is the super interesting question, right? Because we know that the basic neural machinery is more or less the same, and we're just building more complex evaluative mechanism on top of it to, for example, consider reputation. You cannot see somebody's reputation. You have to retrieve it from memory. Remember all the interactions you had, weigh them against maybe some moral background that you have. Not all actions are equal given the circumstances. And that requires a lot of neural machinery to figure out. But in the end, what you're doing, you're sort of biasing your behavior towards one or another alternative based on this information.
So the learning is why we should learn, I guess, is part of it is part of the reason is to how to know who to trust, how to keep track of what's happening, in the sense that how secure is my future?
Yes.
Basically.
Yes. So that is like a survival perspective, which in the context of like cultural learning and the way that we have set up societies, maybe not super relevant to think about, but definitely super relevant when you think about how evolution shaped our neural systems. But I wrote something down here that is at the end of my notes, which I thought it could be interesting to come back to at some point.
For sure.
But it's actually relevant right now. Because have you heard of Carl Friston?
No.
Okay.
Oh, wait. Psychologist.
Yeah, he is a neuroscience psychologist, philosopher.
I feel like I've... hold on. Can I just... Oh, it's already closed. Never mind.
Yeah.
I thought it was open. Anyway, I feel like I listened to a podcast with this guy.
He was on with
Lex?
Lex Friedman.
I knew it.
Yeah.
Man, I can't believe I remember that. But like, yeah.
So Carl Friston is... he developed a theory which he now applies to everything. As you have a good theory.
Yeah. Like classic.
Yeah, and it's basically a principle. So it's called the free energy principle. And his idea is that what brains in general are doing is reducing surprise.
Right. Okay. That would make sense.
Yes. I think so too, but why does it make sense to you?
Okay. Well, I mean, I guess the premise here is that the brain is basically is a predicting machine, right?
Yes.
It's just constantly predicting what's going to happen next, and in a sense, your reality is sort of a prediction, like a creation of the prediction that your brain's making about what's happening around you.
Yes.
Based on the input that it's getting.
Yes.
Okay. Well, so why is it important? Basically, the question is, what that means is, if you are just predicting stuff, surprise means that you're predicting wrong.
Yes.
Right?
Yeah.
And then you want to minimize the difference between what you predicted and the surprise that you get.
Yes.
Okay.
And why would you want to do that? Well, possibly because surprise could mean that something is now radically different in the world and not in a good way, right? So a flood or maybe solar flare or something that really radically changed your input, and now you have to do something else.
Man, solar flares. Yeah. Sorry, random tangent, but like this, I've been thinking about this for some reason. I don't know why, right? As if I don't have enough shit to worry about.
Yeah.
But like, we're like solving other problems. Like, we have AI problems, health problems, environmental problems, right? Like all these problems are good, but we're sort of like not thinking about this thing that could happen.
Right.
And just like put a stop to pretty much everything that's modern, right? Like a solar flare hits, takes out all the electronics.
Big EMP wave, everything
all
dies.
Our money, all of the Bitcoin, all your credit, everything's just, God, that would be nuts. But anyway, sorry.
You have to talk to another expert on that one. I think.
I don't know why I brought up this tangent, but like anyway.
Well, let's there's a couple of really useful analogies from the domain of visual illusions, for example. So one of them is, for example, the waterfall illusion. So if you stare at the waterfall going down, basically, and then you shift your eyes, and whatever you look at now seems to be moving up, because your neural system has adapted to this particular pattern of motion.
Yeah, I took computer vision with last semester, so I spent a lot of time staring at stripes.
Yeah, it's great, right? So it actually apparently even relatively quickly. So this illusion takes place in a matter of seconds. Relatively quickly, you can learn to expect a particular pattern of motion in your environment, and actually sort of stabilize your perception to account for that. The same happens when you're in a train and you try to watch outside, for example. So our brain in that instant is basically trying to filter out this motion because it's now part of the expected input, right? So we're minimizing the surprise because this is now apparently how the world works. The same goes for the fact that we expect things to have edges and depth and mass, etc. You can have this illusion where it looks like something is really heavy and it's not, and your muscles are actually already attenuating to it.
Like this is, I I guess this is like sort of. So I've been also reading. I've been getting curious about quantum mechanics, right?
Mm-hmm.
Which is basically probably the most counterintuitive subject that you can possibly do, because it's so far removed from our everyday our physical experience, that it's kind of hard to see reality that way. So I guess, who was the guy who said I think it's Hofstadter.
Yeah.
It was like we basically see what we need to see to survive. Was that him? I think it was him. But like, our perception of the environment is a product of evolution for billions of years, right?
Yes.
So if we've never had to worry about what up quark and down quarks are doing, right?
Apparently not. Yeah.
Apparently not. Exactly. So we don't know, but like, it's super weird. So like, I don't know why I got on this tangent, but anyway, the point was that your environment, you learn what you have to learn about the environment.
Yes.
To minimize the prediction error.
And we call this the statistical regularity of the world. So basically, you learn what spatial frequencies, electromagnetic frequencies to expect in terms of light. We don't see infrared, we don't see ultraviolet. It would be useful to see it maybe in some cases, but not in the general sense of the world.
So it's weird, like we've sort of developed this ability now to put things in our environment that we just don't expect it. We're just not built to expect. Right?
Yeah.
That's weird. That's a weird thing. It's like we've for example, our environment is full of electromagnetic waves that we created.
Yeah.
On top of the solar and the general universe vibe.
Yeah.
But we don't perceive any of those things. We need a sensor of some sort. Yeah. I'm waving my phone around to be able to perceive the things that you've put into the environment.
Yeah. So you probably know that if you use your phone, it actually allows you to see infrared. Yeah. And so this brings me back to Commander Geordi LaForge, Star Trek Next Generation. It's been, I know this is before your time.
You're really aging yourself here.
Yeah.
But go on.
So he had a kind of a visor which allowed him to see the EM spectrum fully.
Oh, nice.
There's no reason why your retinal implants, if you need them, shouldn't be equipped with also sensors that extend to further into the EM field.
Why would you want to see all the EM waves?
Because it's cool.
It is cool. I guess you could see, like, one thing that really surprised me is that, like, we actually emit light.
Yeah.
Like, because you don't think about it, right? But living things emit heat. Which is electromagnetic radiation.
Yeah.
Which is light, right?
Yes.
So it's like we actually like glowing things just walking around. At some level.
It's your immortal soul.
Yeah, and then you put the visors on, you actually see the body heat and stuff.
Yeah. Well, we already have that in warfare.
Yeah. That's crazy. Like, okay, that's pretty nuts.
But learning.
Right? Yes. All right.
Yes. So learning is basically evolution's way of trying to select actions. I talked about that. And this idea of the free energy principle is that it's basically considers the brain as a Bayesian process, and it's trying to match its distribution of internal states to best represent the distribution of external states to minimize surprise.
So like, and also I guess, could this be driven by just a purely energy efficiency thing, right?
So single neurons, right? They actually regulate their own input. And this usually happens because they send out, if they get a lot of drive, so they get a lot of input, they're passing this on initially, but there's usually like a side connection, a collateral, that goes to an interneuron locally, which then inhibits the same cell. So they're auto-regulating their own input. And this is super flexible because if the cell that is being driven doesn't fire, it doesn't activate the interneuron, and the inhibitory drive on that cell decreases. So if it hasn't been active for a while, you could say it's actually primed to become active.
All right. Interesting.
It's what's the word? A thermostatic regulation, basically.
Oh, nice. That's crazy.
And that is, of course, energy efficient in a way. Because if you're being constantly driven to your maximum firing capacity, it uses up a lot of ATP, uses up a lot of energy.
Yeah, pull this thing closer to your a little bit. Just like pull that thing and just like turn the... yeah, there you go.
Like this. Yeah. All right, sitting back.
Yeah, all right, cool.
Yeah. So it even happens at this very basic level of a single neuron or a single circuit, cortical circuit, basically, trying to regulate its own activity. And that's the first step of adapting to a change in the environment.
So I read this, I didn't read the study, but I remember it being referenced to this study once, where they basically measured the energy consumption of people learning to play Tetris or some game.
Right.
They watched the glucose uptake, and the better they got at it, the less glucose the brain used, because presumably it takes energy to build that. So what is being okay? Oh wait. Okay, this is good. What is being built there? It's not like a physical connection, is it? Or it's just like what is the substrate that is being reinforced and modulated?
Yeah. So if you look at the structural changes in the brains of people who are like world-class athletes, they actually do have more neurons devoted to parts of the cortex that control motion.
Okay.
But also they have more connections, basically, in that space. So in a way, this learning of expertise, right, is something that takes more than a single session. So there is repetition and consolidation involved. And this actually is translated in a biological level to more synapses or more efficient synapses.
So synapses, connections between neurons.
This is basically the hardware, yeah.
So like a physical change in the number of connections between neurons.
Yeah.
Wow. So, and that is energetic, right? I'm assuming it's energetically demanding. Like it takes more energy to do like a whole change than it is to just like keep working on the same paths that you already have.
Yeah. So if you want to learn a new difficult motion, initially the circuits that are supporting this motion and the integration of all of the muscle movements, for example, are
just tilt it down a bit. There
like this.
Yeah.
Oh, yeah.
So it's like it's super finicky, these mics, because like it picks directly what's in front of it.
Yeah.
And then it's like everything else is like, nope, I'm done with that.
Good.
That's good.
Yeah.
All right. Cool.
Okay. So imagine. So all of these motions are very complex, and they involve a lot of muscles and sequencing and organization. And you can do all the things individually, but it's a little bit more difficult if you're up in the air. Basically, you might be doing a triple flip or something. So in order to get that sequence programmed in, you basically need to drive a groove in your brain that links all of these neural representations together. And by repeating it over and over and over again, you strengthen those connections that you need.
Right. Which is... So now...
That's habit learning.
Yeah. But like, it's hard, right? Like, this is why learning things is... I feel like this is one of the reasons why learning things is so difficult. Because it feels difficult, right? I mean, learning things doesn't feel easy.
Learning... I think we have to make a distinction between, like, declarative knowledge, so facts.
No, okay.
And procedural knowledge, which is habits, or riding your bike, for example. The way that you... I think you probably have this experience of being able to drive your bike without your holding with your hands.
Yeah.
And actually also probably with thinking about a million other things and only...
No, with driving. I can drive I'm a great driver.
Yeah.
But I don't think about driving.
No.
I can listen to music. I listen to
completely
podcasts.
automatized.
Yeah, I listen to a podcast.
Yeah. And that's because you've been doing it a lot, basically. And much of this knowledge is now habitual. And you've learned very well to predict the input of the environment, which includes other drivers, the weather, all of these things. Whenever, of course, the combination of other drivers and the weather becomes a little bit extreme, now suddenly you have to pay attention because there's a lot of surprise in the world.
And you're learning a lot of what you're learning is what to ignore, right?
Yep.
Like so when you're driving, so this is something I had this conversation with. I think it was Andre. I can't remember. I have a lot of strange conversations with Andre. Comes up a lot in this podcast.
Shout out to Andre.
Shout out to Andre because I keep asking. He keeps asking me like weird questions.
Yes.
Like, the reason why. So, sometimes when I'm crossing the road, right? There's clearly no vehicle around.
Yes.
Right, but it's red.
Yeah.
And I don't cross. I try not to. Right. And Andre, I think he asked me like, "Yo, let's just cross. Like, what's the big deal?" And I was like, and then I try to tell him like, part of what makes the road safe for me and for other people is that the person driving is sort of doing it automatically, a big part of it automatically.
Yes.
Right. So he's trying really hard. The person is trying really hard to make a lot of things irrelevant.
Yeah.
Right. So if everyone can trust that when it's green, I can go and no one's going to jump into it, it makes the whole driving process much easier for everybody.
Yeah.
And conversely, once they've trained that, they're not going to see you cross, even if you're wearing a bright red. I mean, they might see you, but like the brain is just trained to focus on that one thing, that one signal that makes the entire process easier.
Definitely.
The brain just uses the path of least resistance. It's like, oh, that gets me the answer. Like, I'm gonna go down that way. Like neural networks for computer vision are interesting like this. Like if you take a pixel, take one pixel, and you code the right label into just that one pixel, it'll ignore everything else and just learn that one pixel and then get it wrong. Even if you just remove, you can have this huge network.
Yeah.
And remove that one little pixel, and it's like, nope, no idea what this is.
Yeah. Yeah, that's the charm of these adversarial examples as well, right? So you change a little bit, and now suddenly it's a different class, and that would never happen with a human brain, basically, or human observer. Yeah, I think it's mostly because all of our neurons have a pretty broad tuning curve, so they respond to a lot of input that is similar to its preferred input. Whereas in neural networks, you can have a very, very narrow driving input, basically.
Yeah, if you think about the range of stimuli that we get is nuts, right? Like for example, when the light is on or like the sun's out right now, we perceive it as a constant,
and it's definitely not.
It's definitely not constant, right?
The amount of photons is like orders of magnitude different.
Yeah, it's changing like second to second to second to second, but we perceive it as nice, smooth, constant. That's like, the amount of work that the brain puts into making our environment seem constant and nice and smooth is nuts.
Yes.
It's a lot of work.
Yeah.
That's crazy.
Yeah. Props to the brain.
Yeah, for real.
So last time we talked about the reward prediction error. Yes. It's assigned level of surprise or mismatch, basically. So it can be better than expected or worse than expected. And people correlate this to dopamine. But earlier learning theories were based on behavioral experiments. And there was a lot of competing ideas in that space. And one of them that I want to highlight is what's called the Peirce-Hall theory of surprise. Now, surprise, in that sense, is just the reward prediction error, but then in the absolute, right? So whether it's negative or positive,
right.
Just take the absolute, and the only thing that matters is the deflection. Yeah. And the idea was that this deflection of this surprise triggers a learning state in the brain, so that the brain, by encountering surprise, now changes its internal state to become more teachable. So,
that's interesting.
Yes.
Because we know that learning happens when you have sort of like you learn faster, like when you're in a heightened emotional state, in a sense, like when you have a signal where it's like, okay, this is super unexpected.
Yeah,
we should probably try to figure out what the hell happened here.
Well, there's an optimum, because if something is considered super anomaly, then it's not that useful.
Why is that?
Because if you learn for each anomaly, then you're basically learning instances rather than pattern or gradient.
I see.
Yeah.
Right.
But my favorite example is basically when you're going from a regime where there's relatively low surprise to a regime where there's relatively high surprise. And you can think of this basically by visiting a country that you never visited before. So most of the things are still the same. The sun is out. People are maybe driving a car. But everything else is different, right? And things that you consider fixed in your home environment might be not fixed at all in the situation where you are. So if you would be... if you would use the absolute size of your reward predictions to update your nervous system, there's quite a big chance that you're going to override whatever you learned over the last 20 years, because you're just all over the place now. And the rewards, the errors, the surprise is just too big. So is that useful? Probably not. When you're in a situation where your uncertainty basically is high, so uncertainty is like correlated to surprise, I think, right? When your uncertainty is high, then it pays off to dampen your learning rate a little bit. So basically, you're now in a regime where you're expecting to be surprised all of the time.
Yeah. So like this is like a signal to noise ratio problem.
Exactly.
Right? Like, what should you pay attention to versus what shouldn't you pay attention to?
Yeah. And there's a thought that, for example, serotonin is involved in signaling this level of uncertainty, and maybe noradrenaline as well. Yeah. Whereas the dopamine is still more related to signaling the individual events as they happen, basically.
Nice. I wanted to ask you about the relationship between acetylcholine and dopamine. They play from what I know, they play an important role in learning. Like, if I can remember correctly, sort of acetylcholine marks the things that needs to be learned, and then dopamine goes in and reinforces these things. I don't know, something very loose and terrible like that. But this is like, actually so this is like, I have a good series of conversations coming up. So after I talk to you about this, I'm talking to Giacomo about reinforcement learning in machines, and then I'm talking to Peter Hendricks about information theory.
Great.
Because like I want to get an information theoretic understanding of like what it means to be surprised.
Yeah.
Right. And why shouldn't you be surprised? Because surprising information is informative, right?
Once you are surprised, you should do something with it. Yeah. Right. But basically, the goal of the brain is to be not surprised, according to Friston.
That's crazy. I mean, do you think that's how what do you think about that? Like, it feels like it makes sense to me.
Well, in our highly sort of structured world, I think that you can bring this to a level of non-surprise that is actually boring, and there is evidence that people are auto-regulating the level of surprise that they want to encounter in the world, up to the level that is appropriately stimulating for their brain. We've talked about this last time, right?
Yeah, that's interesting.
People who are seeking out danger or at least adrenaline, maybe.
Thing is, you don't, like you said, you don't want surprise in all your domains, right? You want surprise in certain domains. You don't want surprise in you don't want to go home and find that your house is gone.
No. Fair enough. Yeah.
Right. But some domains you actually want to be surprised, like music. You know, like it's like, I want to see something different, something cool.
Yeah, so you can put yourself in a vulnerable state, basically, where you're playing maybe with your own expectations a little bit, and you're making yourself ready to be surprised.
Okay,
learn something nice.
This is okay. I'm not sure if I should say this on recording, but I don't care. All right, doesn't matter. But like, so every 6 months or so, I'll eat some mushrooms, right?
Yes.
Some truffles. And the way I think about it is like, I've reinforced this. I think of it as a period of increasing my, like, sort of like a random restructuring of my learned patterns of behavior.
Yes.
So because how I got into this practice was because I was suicidally depressed for a while, and I think it was like my last year of university in the US.
You should put a trigger warning here, I think, right?
Yeah. Well, if anyone's been listening to any of my other episodes, like it's too late. But okay, because I'm pretty open about this. I have no problem talking about this because, like, if anyone can derive some sort of. By the way, I'm not recommending this to anybody. I'm not a medical doctor. That I'm not making any recommendations. I'm just conveying my experience, right?
Yes.
Be that you do with that what you will. And I'm pretty open, so I have no problem sharing about this. But I've been dealing with this for a long time, and one of the things I realized when it was really bad was that I was stuck in these loops of perception, cognitively, like perceiving something, then assessing what happened, and then reacting to that thing.
Yes.
I realized that at some point I was stuck just doing these same loop over and over and over and over again. And the psychedelics sort of helped me realize that, like, I know this seems normal to most people, but for me to realize that I don't have to think this way,
right,
was huge. Because, like, it never occurred to me. Like, it never. Cause if you're like depressed like that, it just doesn't occur to you. Because, like, your brain is just not an option that appears to you in the realm of doing stuff. Like, there's a great game called Depression Quest. It's a web-based, like a text-based game, where you sort of live the life of someone who's depressed,
right?
And what they show you is like, so you're like, they give you a thing that's happening, or you feel really sad. I don't feel like doing anything, right?
Yeah.
And they have a bunch of options, like, change my perspective, just suck it up, get it done. Like, talk to a friend. All of those are crossed out. Like, you can't select them because they're just not options, right?
Right.
So when I got myself in this state, I was like, holy shit, like, I don't have to think this way, right? And
you don't need a purple rabbit to tell you that.
Yeah. You don't have to, like, you like you don't have to, like, and then I did CBT, and then, like, a bunch of, like, I mean, I have actual therapists who's helping me.
Of course, good for you,
right? And, like, and I was really lucky that. So I know people who go to therapy for years, and so I tried psychologists first. Yeah, I mean, super helpful, super useful, and then I just didn't. She recommended that I see a psychiatrist, try to get some chemical assistance. Yes, I was really lucky because my psychiatrist is great, and, like, he just managed to find the right combination of things that works for me. Yes, I know people spend years trying to find just the right combination, right dosage, and right psychiatrist to help them figure out, like, to get out of this situation they're in, right? Yes.
So, a couple of perspectives.
Yeah.
Right. One of the things you mentioned, you got antidepressants, which are neurochemicals, which do something with the chemical balance in your brain. Right? And this obviously has effects on your internal state, your internal model, which then can basically reinterpret your external stimuli in a different way and get you out of this rut on one way. What are the alternatives to this? It's things like transcranial magnetic stimulation or electric convulsive therapy. And all of these treatments have in common that they're basically trying to reset or shake up your neural circuitry that is processing the same stimuli and the same social interactions over and over in the same way, right? So it is like the depressed brain in some way is an attractor network, which is self-reinforcing because you're also shutting out positive social stimulation, for example. And you get sort of in this deep well that is pretty difficult to get out from without a restart.
It's like a pathologization of this brain's awesome ability to minimize, to use as little energy as possible.
Yeah.
So it's like stuck in this loop that keeps this is great. It's not able to. So how does it know that this is a loop I should get out of, or this is a loop I should stay in?
Well, every once in a while somebody tells you, right?
That's true.
And we're not creatures that are completely driven by stimulus-response associations. We just rely on them a lot. And sometimes it takes someone to give you another perspective or to make you reflect. And temporarily this can access, memories of happiness or whatever you need to visualize basically a different you. And you can try to work towards that. So Friston says you can, if there is a mismatch, you can try to change your internal model to now update your stimuli that are incoming, or you just choose different stimuli to update your model, to basically match your model. So you can think of this as someone being in a very bad environment, recognizing this and actually trying to change the environment because they don't want to change their internal models.
So I took an evolutionary psychology class last semester.
Mm-hmm.
I have mixed feelings about that class.
Yeah.
It was nice when it was, I don't know, it was hard to tell where the science started and the politics began.
Yep. It's a lot of post hoc ideas, basically.
Yeah. So I was like, okay, well. But as far as I could look back and look at actual papers, there was some good stuff. Like one thing, how your life, your early life environment sort of trains your brain to expect certain things to happen.
Definitely.
And expect certain things to not happen.
Yeah.
And that was pretty interesting to think. And so I maybe think about certain kinds of behaviors that I have that it gave me a context to think about.
Mm-hmm.
I had a really good, I had what I perceived to be a good childhood, right?
Yes.
I never thought about it. My parents did everything they could for me, which is awesome. And then I was thinking, okay, well, certain behaviors seem ridiculous to me. Why do I do this, right? For example, I will, my relationship with food has always been really weird. And I don't know if that was because there was a time in my childhood where we didn't have a lot of money.
Mm-hmm.
And we had to, it was rough. I mean, it wasn't bad. It was just it was really tight.
Yeah.
And I can't tell but I don't remember it. I don't remember it overtly as being bad, right? Or difficult. But I wonder if it's like something that I've learned somewhere, right? Because, for example, I've had to come up with a strategy so that like I'm not eating all the time.
Yes.
In a weird way, it's like I can't stop eating just because I feel full.
Yeah.
Right. And I was like, what the hell is this? Right.
Yeah.
But now I have a strategy which like I only eat from this time to this time and then I'm done.
Yeah.
And that helps me a lot.
Yeah.
And I was like, okay, well, maybe in my environment I learned something where it's like you eat when you have food because you have no idea when the next meal is going to show up.
Well, think back to the vampiric bats, right? So if you have a good meal, you should feast on it, basically, because you don't know how long you're going to be until your next meal.
Mm-hmm.
And in the human nervous system, there's these neuropeptic, peptidergic or hormonal pathways involving ghrelin and others that basically mediate your sense of satiety and hunger. And those are also released in the bloodstream through nervous connections with the hypothalamus and the pituitary gland. So they're subject to learned connections.
Oh, nice. Okay.
So particular sensory inputs or sensory configurations can, in some people, trigger a massive like hunger or feeling, for example. And these can also be internal, right? So the feeling of having just eaten, for example.
Like I certain things like I don't drink anymore.
Yeah.
But the smell of apple flavored alcohol just makes you want to like it's just an immediate like a vomit reaction. Like it's it's like I can't, because
I have exactly the same reaction.
It's just terrible.
There was too much of it at some point.
Exactly, way too much of it. Like all these flavored things. Like I can't even stand being around them.
So this is called conditioned taste aversion in the literature, and it's actually been studied a lot because the funny thing is that you have updated your mental model of how valuable this particular flavor is because it was paired with illness. In my case, maybe in your case as well.
Yeah.
And now, the next time you are considering taking an action that might lead to this particular outcome, now also the memory of this illness is being reactivated. So this is called outcome devaluation. Something that you thought was very valuable has been paired with a negative outcome, and its incentive value has been decreased a lot.
Man, this is so like. I wanted to ask you, is it possible to be addicted to somebody?
I think that's a very difficult question.
So let's try to define addiction. Like what do we consider addiction? It's generally negatively connotated, right?
Yeah, so addiction is basically defined as having a negative impact on your social functioning due to the fact that you're consistently obsessed and planning to obtain this particular thing that you're addicted to.
Okay.
So it is mostly defined in terms of social dysfunction.
Mm-hmm. Okay. So this is this is interesting because like this is basically a therapy session. Like Lex has for himself.
Let's go there. Yeah.
Right. I'm taking after him quite a bit here because like I've had because I was thinking about like why certain relationships are, to me, super engaging, and I really like pulls my like motivation the same way video games do.
Yeah.
But I've had in my experience those relationships were the worst for me and for the people around me, right? Yeah. But they were hyper motivating, and they were like they hit the same. They felt like they hit the same buttons, like. You know, when one of the feelings that I love is not solving a programming problem, but being just close, you know, like not like
you can smell
it, like being so close that you can smell the solution.
Yeah,
that feeling is this mix of frustration and enjoyment. That, you know, I could keep working on. Like, I don't need a break. I don't need to stop. I can just keep working on this 8 hours all day, right? Because it keeps driving me forward, keeps pulling you. It's like dopamine. It's like, hey, it's over here. Come on, keep coming.
Yeah,
it's the same feeling I get with certain relationships.
Well, this is. I mean, we're getting out of my comfort zone a little bit.
Okay,
but. If you think about the sort of the patterns of behavior that are common with people with borderline personality disorder, for example, it revolves around giving out intermittent rewards and creating a highly variable and unstable environment, which can initially seem very attractive because you're now in a more high stakes and more surprising environment, but long term this is destructive.
That's a very good characterization of what I was experiencing, because like the range of responses, the distribution of responses that I get from these people is so vast.
Yes,
that I like. It's like they like something today, and then I'll repeat the behavior the next day, and they'll be completely appalled by it. And I'm like,
Yeah.
what?
And the problem is that this puts you in a high variable learning state, which also affects the rest of your life, where you're considered to be functioning in a stable environment, right? So if you're, this is generalizing a lot, but you would probably be keen or prone to project the same expectations on your coworkers and maybe react quite disproportionately to the same kind of input.
Yeah, so now I'm very careful about sort of like the training examples that I give my brain.
Yeah,
I take care of my brain much better than I used to.
that's good for you.
You know, like I'm like, okay, man, I can't be like, I don't know, like for most people, like there was a time in my life where sort of getting up and doing anything was just like, was out of the question. It was like, why should I do, why am I even here? Like, what does it even matter, right?
Yeah.
And I realized like I have to take care of the environment to a certain degree to keep me from like going back. Because like for me, everyone has their problems, right? Everyone has a freaking bullshit burden to carry in life. That's it. I understand that, right? So like you have to sort of, I had to sort of build systems around me that help me do these things, right? So for example, I give myself a certain number of hours a week, a certain number of hours a day to do productive work things.
Yeah.
And the moment that it hits, I'm like, I'm done. Like I'm not allowed to do anything else. Because like I've had to negotiate with myself and compromise with the part of me that's like, let's just sit around and watch Netflix all day, every day.
Yeah, or be coding 24/7.
Yeah, exactly,
right?
exactly. So like, I'm like, okay, no. Like, so yesterday, I wanted to keep working so bad, and I was like, man, I'm almost done. Like, come on. And I was like, no, it's too late.
Yeah.
You pick up tomorrow.
Yeah. So you're basically homeostatically auto-regulating in a way that works for you, and I think that's great. And obviously, people can push themselves here and there, right? But I think it's probably healthy to make sure that you do push yourself towards a regime where most things are predictable. And this includes, for example, stable social interactions.
Yeah, it's hard to be around super volatile people. Like, especially like, depending on, like, I like to have things like, I don't know, I guess I like to have things fairly, it's weird because like I will allocate a certain part of my time to allow random things to happen.
Yeah.
But it has to happen in that time.
Yes.
Right?
Yes.
And then like I need some semblance of like stability.
Yeah.
And it helps.
I remember we talked earlier about, in class actually, about sort of diminishing marginal returns. So anything that you take over and over again, if you get more of it, basically the returns that you get from it are diminished. So there's a benefit in variety because it gives you this initial boost, basically. But in order to sample a variety of rewards in your environment, you have to have a lot of flexible strategies, and that goes against exploitation. So it requires more energy to do that. So obviously there is an energetic, but also motivational optimum somewhere where you have a couple of strategies that give you this baseline of what you need, and on top of that there is a flexible layer where you can get sometimes you get a real nice high, and sometimes maybe it's you're bummed out for a week.
Yeah.
Can happen. But recognizing that and auto-regulating that, I think, is a life skill.
For sure. Man, like teaching your brain what to expect is like a full-time job. It's like,
yeah, well, luckily it teaches itself.
Yeah. Thank God. It's really good.
It's not supervised. This is all unsupervised.
Yeah.
And all of these homeostatic aspects are maybe driven by energy efficiency, but they also teach us. They let us experience stability and it basically it allows planning, right? So if everything is random all the time, how can you do any planning? There's no sense.
I highly recommend for anyone listening to read The Molecule of More. I don't know if you heard of it, but it's just about like dopamine. It's a book about dopamine and serotonin and so like the rest and relax chemicals versus like the go get stuff. People think dopamine is about feeling good, but it's actually about motivation, right? Making you go do things.
It's the opioids that are about making you feel good.
Mm-hmm.
So revisiting the benefit of shaking up your brain. This is exactly what psychedelics do. So basically they change the functional connectivity in your brain, allowing like uncharted connections between brain regions to be activated, and this usually transforms to like transcendental experiences or unexpected insights, possibly because these are relatively new connections that are being facilitated at that point, still using the same neural hardware, but because like all of the traffic lights are in different colors, suddenly this is possible.
Yep.
Obviously, you don't want to live in that state forever.
I was about to say, it's like it's not a livable state, but like there seems to be. Isn't it weird that? Well, is it weird that our brain has the? I guess it's not that weird. It's just a chemical key in a different lock, right?
Yeah, you can short circuit anything, right?
Yeah.
And most of the time you destroy things if you do that. But in the brain, because all of the input is auto-regulated, if you switch one highway from, it's like mini motorways, basically, if you know the game, but you can basically move a highway all of a sudden, and it is has a vast impact on the traffic, the flow, basically, in your brain. But the brain is very good at protecting itself. However, there's also a connection with PTSD and, for example, EMDR therapy for people who are suffering from trauma, because they interpret particular sensory input over and over in a negative way, and this heightens their vigilance, heightens their emotional response. You get into this mini trough, this mini well that can be super salient to people on very specific triggers, like the sound of a car backfiring, for example. Yeah, that's a typical example. Now, what is the idea of EMDR? Basically, it's trying to distract you, doing something else, and therefore desensitizing the input a little bit, allowing you to experience the input without the immediate stress reaction. And by just doing this over and over again, you're sort of trying to bring the homeostat or the thermostat down, right, on this particular circuit.
Right. So, you mentioned supervised learning. One of the things that sort of has given me a sense of me being the supervisor of my learning experience,
yes,
is meditation. So like I've been meditating for years now.
Yeah.
And it's really helpful in the sense that I'm sure it helps on a day-to-day and like a normal basis as well.
Mm-hmm.
But when I have a really stressful experience, or when something anomalous is happening,
yeah,
I have trained this ability I immediately go into like a 80,000 foot like a out of overview. Yeah. It's like, okay, this is happening.
Breathe through it.
Yeah, relax. Right, it's gonna be okay.
Yeah.
Like the most salient example of that was 2019 something. Right before I started this, I got kicked out of my house.
Yeah.
With like no warning. Right, basically.
Big surprise.
Like so. And like it was a bad situation, and this guy just sort of, who is my uncle by the way, showed up and started breaking down the wall in my house, right?
Ouch.
And I was so in that moment I was like, so imagine that moment, right? It's like I just came home from the gym.
Yeah.
And I was like,
what
is happening right now? Right? Yeah. My parents were afraid. I was like, but in that moment I had this like sense of I had this feeling of like I was watching myself in that moment.
Yeah.
And I sort of dealt with that in as well as I could have dealt with it, right? So that no one lost their mind and got hurt, and like I handled it the best I could until the cops came and like tried to sort this out, right?
Yeah.
And that sort of bites me in the ass now in some other ways. So when I'm with people, especially in relationships, let's say, right? The number one, if I had to take my relationships,
Yes,
and take a principal component analysis and get the first component of like the most the biggest problems that I have.
yeah,
The biggest problem I've been criticized for is apparently I am cold.
not in the moment.
Yeah, right. Because I don't react to the emotional sort of output
Mm-hmm.
that people tend to give in a heated situation. It's like, I don't know if it's just the way I am, but like, it's just like I just sort of like look at it and think, okay, this is a thing that's just happening. How should I'm able to be like, okay, how should I react to this? And then react differently. Whereas most people seem to be just like a little more coupled to the output. It's like, okay, it's just like all I've accomplished after years of meditation is being able to put a slight delay between perception and reaction,
Yes.
right? And that seems alien to most people. It's like this is happening. So I'm like, okay, cool. Just not even just having that pause has been super helpful. So I can sort of say, okay, what am I supposed to do here? And I always think of my actions in a way. I think of it as reinforcement learning. I think, okay, if I do this now, this is the training that I'm giving to my brain to make it do easier later.
Yeah. So, I mean, you know about there's like these subcortical systems that are mostly intuitive and automatic, dealing with emotion, and then there's sort of the cortical systems that are mostly control systems, right? And training yourself to take this pause gives your cortex the opportunity to catch up.
Yeah, exactly.
Because of those loops are also slower than the fast process that goes through your amygdala to your hypothalamus, and then it's like, do something.
Yeah.
I think it's process that can be trained. So it's like your executive function that you're strengthening as a muscle, impulse control. We know that people can differ a lot on impulse control based on their brain chemistry.
I read this amazing quote. It's like, what you do when you don't have to determines what you do when you have no choice.
Yeah.
Right?
That's about making habits then again, right?
Yeah.
The same, it relates back to your story about the traffic light. So if you make it a habit to never cross when it's red, then the chances that you're doing it inadvertently when you're not paying attention is much lower. So you're making it safer for your future self as well. Because this is the rule, you never break it, and that's going to help you at some point in the future.
Like, that's sort of like the... like sort of the strategy I take, for example, for studying, right?
Mm-hmm.
So I try to study consistently over the semester.
Yes.
So that when it comes to exam time, when I have to study, it's on the plus side, I study consistently.
Yeah.
That
has its own benefits.
Yeah. And on the other side, when I have to really go take it to 11.
Yeah.
It's not that extra strain because I've been doing it over and over again.
And probably you also have to do less.
Yeah. Exactly. So it's talk about non-linear, like reward on.
It's compounding interest.
Compounding interest, exactly.
Yeah.
Okay.
You're being very friendly to your future self.
How does the brain deal with compounding interest stuff?
We're very bad at judging slow processes, drift, because the brain is constantly adjusting for it. So, you can really get lost in trying to follow a pitch if it's going up very slowly and then suddenly it's something else. There is also these visual illusions where, then things in the background change very, very, very gradually, and you don't see them because you're paying attention to the high frequency thing.
I'm sure you've seen that.
The monkey.
Yeah. That really.
The bear, yeah.
That. So the people who haven't seen it, it's like this illusion where people are passing a basketball around, and you're told to count how many times the basketball is being passed between people.
Yeah.
And a full-sized human being in a gorilla suit walks right through the thing and bangs his chest and walks away, and you completely miss it. Most people don't see that happening.
So I think that is mostly selective attention, because your attention is really drawn to a very high frequency detail, this little ball that's being passed around, and you don't see the rest. And that can happen also on the road, for example. You don't really notice what's going on the sides. This gradual change is something else, because you're definitely paying less focused attention, but because the rate of change is so low, you don't really see it happening unless someone points it out, and then you see it immediately. Or if it loops around and then you connect back to the color it used to be, and you think like, what just happened?
Yeah, right?
Everything is green now.
Yeah.
Same, of course, applies with color correction and brightness and intensity correction when you're just outside. It's very gradual. But if you're going from the inside to the outside, you experience this overload.
Damn. So, I think so. Like I said, fair to say that. So you made a distinction between habitual learning,
yes,
and learning factual,
goal directed also.
Yeah.
Sorry. Yeah. So basically, habit learning and so this is about knowledge. What you were saying. There's habitual knowledge, knowing how to do things, and there's declarative knowledge. Facts.
Why the distinction?
Because they're stored differently.
Okay.
So habits are stored at the level of the basal ganglia, basically, in the motor cortex, motor systems, whereas declarative knowledge is stored in the neocortex. Like a scene is made up by sounds, smells, whatever, textures, everything, and they have their own representation in the brain, and they're being bound together through the hippocampus. So the hippocampus basically makes the initial connections between the components, stores those, and can actually also retrieve them. So reactivate those individual components that make up a scene or a memory or a fact, basically. So it's different. They're stored in different places. They are dissociable. So that means that there's patients that can do one thing but not the other, and another group that has the exact opposite pattern, which means that it's localized in the brain to different regions.
Is it more expensive energetically to learn build habits than it is to learn factual information? I feel like factual information, you got to keep refreshing that.
Yes.
To keep it in your brain.
The point is that you learn new things during the day, and those are stored in short-term buffers, basically, through the hippocampus. And then at night, you are consolidating those experiences.
Oh man,
sleep.
Sleep is a whole.
Oh, that's a whole thing.
That's a whole thing, right?
Yeah.
Man, it's crazy. Like, so apparently your brain modulates the amount of deep sleep and REM sleep by a little bit, depending on the content, how your day turned, how your day was,
how much surprise
there
was in your day. Yeah.
How your day went beforehand. It's nuts.
Also, maybe the amount of stress, cortisol, definitely has a big effect on that.
For sure.
Yeah.
Like one thing I've noticed, like for example, is I've realized, maybe like it took 3 years to realize this, but like when I'm trying to understand something, right? So like give an example is recently I was just trying to build a neural network from scratch with just NumPy, and I was like, okay, how the hell do I do this? Right? Just following the equation, just like
sure.
Here's the equation, and it was really hard, right?
Yeah.
But what I realized, like I spent all day banging my head against this, all day, literally 9 hours.
Oh yeah.
Went to sleep, got up in the morning, like sat in my computer 20 minutes. I was like, oh yeah, I got this. That makes sense. And I was like, man. Yeah. So the right reaction is, why didn't I figure this out yesterday? The right reaction is, of course you didn't figure it out yesterday. Your brain needed the 8 hours.
Connections were not there. Yeah.
Because so the best experiment of this is like they recorded the brain of mice as they learned a maze, and then they let the mouse go to sleep, and then they played back the sound.
Yeah.
and it was like the same pattern but in like 10x speed.
Exactly, because the brain works a lot faster than when you're actually walking.
Yeah, that's
around.
crazy, right? So when you're awake, your brain is also coupled to your motor output system.
Yes.
Right, which has to work in a much slower time scale.
Yeah.
Than the neural firing.
Exactly. So your brain is like reviewing that in high speed.
Yeah, it's crazy. But you have to put in the work.
Like the Matrix.
But you have to put in the work.
Yeah.
That's the thing, right?
It's not for free.
Yeah, it's not for free. You have to put in the work first, and then at night it's like, okay, I got this.
So let me tell you one more thing. I think maybe it's
it's
a good thing to tie this all together.
Yeah.
Because what is the function of sleep?
A lot of things, right? But I don't know. Like, I feel like you have a point here.
Sleep is essentially also a homeostatic process. So what you're doing during the day is that you're learning new things continuously, and basically you're strengthening your synapses. So all of this activity is making new connections, and that also goes rapidly. So something that is new is basically strengthening a synapse more strongly than something that is already there, because there's no need to further increase. Right? Also homeostasis. So basically you're filling up your sensor banks, you're filling up your buffers with all this new information. But what about tomorrow? You want to learn something tomorrow, right? So what is happening during sleep is a process called synaptic scaling. All of your synapses are turbocharged during the day. What sleep is doing is basically scaling everything down. And the things that were upregulated enough, those maintain. The things that were stimulated but were not super relevant, those actually get washed away.
That's
so
crazy.
It is implementing signal-to-noise filtering. It is pre-whitening your brain for tomorrow. And it's selectively keeping active those learned connections that, were probably relevant. So if you wake someone up who has been downhill skiing all day in the middle of the night and ask them, what are you thinking of right now? It's all of the times that they fell on their face. Because that's arguably the most relevant thing to learn from downhill skiing is how to not fall on your face.
Right. And also, I've had the experience where if I'm, the sleep towards the end of the night is more REM sleep than towards the other parts of the night. And I noticed that if I get woken up during my REM sleep, I'm super depressed. Like I feel really sad. Like and it persists for a while. Because like apparently the REM sleep is where you're sort of doing like a self-therapy situation where it's like you're just playing through all this stuff.
Yeah, it's like your generative model that is being. So basically, your brain functions in pattern retrieval mode, and whatever random information is flying around, it activates patterns. And through associative networks, it activates other patterns. So your GAN is basically serving you up whatever is its prompt was.
Right.
The prompt being like a distributed electrical activation.
Yeah.
And that's also why if you give someone a smell during their sleep, this can actually trigger memories, right?
Yeah, you can if you're studying and you have a certain smell, like aroma when you're studying, and you go to sleep, and you play that, so not study, but memory. Yeah. You play that, you reintroduce that smell or sound, it increases the recall of that thing you were trying to learn when you're...
Yeah, seems plausible.
So you can bias but like I was thinking about, should I bias my sleep towards certain things? And I was like, you know what? I'm going to let my brain figure that out.
Yeah, it's probably smart.
Right? I was like, I'm not playing with that game. Like let it work through the things you need to work through. I'll put the work in and then let sleep do its thing.
Yeah. Otherwise, you get like super smart Udesh, like emotionally a mess.
A mess completely. Like I know I know every little detail about a neuron. Can't hold a conversation to save my life.
Yeah.
But yeah. All right.
Let's leave it there. Huh?
Yeah. Almost 90 minutes. That was awesome.
Awesome.
All right. Thanks again, Marijn.
Very welcome.
We should definitely do this. Next time I'll come up with a different thing to talk about.
Sounds good.
And we'll figure it out.
There's a lot of neurobiological frontiers that we can still explore.
Oh, absolutely. For sure. All right. Thanks. See you later.
Bye.
This has been another episode of the One Deeper podcast. Thank you for tuning in. Catch you on the next one.